in the interest of time, I think what we'll do is we'll take questions at the very end, because our next presenter is a little crunched for time. So we'll go ahead and get right to Lucas Johnson with Valley Homes to pop on and provide us the next presentation. Just a reminder, this presentation is being recorded, but I'd like to give a huge thank you so much for your time to the presenters today. And yeah, we'll go ahead and take questions at the end. Keep them coming in the chat, and join us at the end for discussion as well. Lucas, I'll give you the floor. Welcome. Good to see you.
Thank you, Nina. Yeah, it's so nice to join. And I apologize for the chaos today. We just got into San Diego. It's a vacation week in Tucson for children. So we decided to come out here, and yeah, it's getting towards their bedtime. So
understandable.
Yeah,
Enjoy
so
San
sorry for the
Diego.
rush. Yeah, awesome. Well, I will pull up my presentation here. Are you seeing that okay? All right.
Looks great.
So we'll get into who I am on the next slide. Nina already gave a nice introduction. Thank you very much for that. And this presentation is called It's Time to Value CO2. And that little E is equivalent. We'll get into that in a minute. A massive thank you to Builders for Climate Action for putting together this BEAM tool, which is Building Emissions Accounting for Materials. What I've loved about this in the process of beta testing this tool is that we can finally talk about carbon in units of carbon. One of the most important things in science is to have common units through which to discuss things. For a very long time, we've been using proxy units like, say, kilowatt hour savings, energy efficiency, as our proxy for carbon, and that has caused a lot of suboptimal outcomes. So who is Valley Homes? First and foremost, we're scientists. Above all else, our background, our degrees are all in science. We take a scientific approach to everything we do, from the language you use around, we don't have like an opinion or a conclusion. We have a hypothesis, which then we collect data on, becomes a theory, for instance. We're developers. I know that's a little bit of a dirty word historically, and probably well-deserved to have that negative reputation. We do development as applied research. This photo in the background is a rendering of our 4-unit complex we're building in Phoenix at the moment. It's intended to be the lowest carbon per square foot building built in Phoenix at a residential scale. And we'll be hopefully finishing that by the end of this summer. And yes, so everything we do, again, is science, and whether that's applied research or theoretical research. We're what we call good building activists. Good building is a term we've started using instead of green building. I have heard a lot of people in my career say that they don't want a green building. It's pretty challenging to get someone to say they don't want a good building, right? Could be great. Great might be too much. That might be too ambitious, but I don't think I've ever heard anyone say I don't want a good building. So it's this concept of what is enough to be good without necessarily having to be all the way to great. Because if we're real, most people, including myself, can't really afford great. I can afford good, but I can't afford great. My business partner and I were both concerned parents. Austin just had a second kid a couple days ago here, so he's not joining us tonight, but congrats to him. We are big outdoor enthusiasts. If we're not working, we're probably exploring the great outdoors. And I have had to put ish recently. We're stoic-ish leaders. We take having a calm, fun approach to things very seriously, in the sense that fun scales organically. So we want to be having fun doing this work. We don't want to use fear to scare people or anything like that. We want to use a beautiful vision of the future as something to motivate people. But maintaining your calm and this stoic approach in the current construction market, I'll say stoic-ish. So this is Austin. He's my business partner and the founder of the company that I joined. And this is me, Chief Building Nerd. And thanks so much for joining tonight. Oh, I'm also very proud to serve as a board member of the Northwest Eco Building Guild. It's been my favorite organization for a very long time now. in that I think the most special part about it is it's an organization that's based on inspiration, education, and not being set on one given standard, just the general concept of eco building, not a specific certification, but the general idea, which is pretty impressive that it's been able to exist and grow for so long without having itself tied to something specific. So what's the big picture? Well, humanity is going to have a really rough future without some radical changes in social justice in the built environment. Just setting some context. And carbon isn't just up front, as in it's not just embodied carbon, but it's also not socially just up front. Whole life cycles are built upon embodied injustice. If this is a concept you're interested in digging into, I've been working on a series of presentations and some research around this. My wife is a cultural anthropologist. She's a professor at U of A. That's why we live in Tucson these days after leaving Seattle. So anyhow, this is a very important subject, but not the subject of the day. It's our imperative to solve this problem, these problems being carbon, social justice, and the less than ideal way that we have been building historically. A lot of what we're doing might not be helping. There's a lot of very well-intentioned, truly good people who are out there spraying stuff like soya spray foam, thinking they're doing a great deal to help improve the world, when in fact they're probably not. I've used this quote in many of my presentations. It's one of my favorites. Our greatest fear should not be failure, but of succeeding at something that doesn't really matter. And the tough pill, I guess I'm going to ask everyone on this webinar this evening to swallow, is that our incredible strides towards creating a more energy efficient built environment have not necessarily been beneficial for carbon. Turns out when you use more bad ingredients to reduce carbon impact, it doesn't actually work out often. So there's a lot of certified buildings, and this is not a dig on Passive House whatsoever. Passive House is incredible. You should do it if you can afford it. It's an absolutely wonderful standard for efficiency, but it's incomplete in that it doesn't look at where the largest piece of the carbon comes up in as great detail as it does with energy efficiency, especially not yet. It's definitely moving that direction. But what I ask is to not feel bad about past work. Don't take this as criticism. Just say, you didn't know about Passive House or energy efficiency at some point. This is just like learning about those exciting new things again. We got to do energy efficient building, but we have to do that building in a, with energy efficient products, like carbon effective products, as I like to call them. So a lot of these certified buildings, as I've talked about, don't deliver holistically. The guy in the center here is Chris Magwood. He's been a huge inspiration for me. I particularly love that he created an elephant out of carbon dioxide molecules to talk about the carbon elephant in the room, which is very much that we have been ignoring to the large degree upfront or embodied carbon, the material carbon emissions as they've become called within this methodology I'm talking about tonight. In addition, beyond the carbon, there have been a lot of other failures. Valley Homes has put together a system we call the 5 factors of good building, which is a design tool to address comfort and health, efficiency, renewables, durability, resilience, social equity, embodied injustice, and life cycle carbon impact, plus a lot of other stuff, but those are really the core features that we look at, other stuff being cost, constructability, making the project real, usually important. But today we're going to dig into life cycle carbon impact because it's really one of the most misunderstood concepts in the built environment at the moment. So what is the carbon life cycle of a building? Well, our focus today is what we call material carbon emissions, which is, in this case of the BEAM tool and the way that we talk about this, it's the first part of the EPD, the A1 through A3 part of the analysis, which is mostly the raw material extraction, processing, and the manufacturing of building materials. This is controlled by suppliers and manufacturers, not so much by builders. This, as professionals, is the area that we can really control and work hard to reduce, right? Can we reduce the impact of transporting things to site? Can we reduce the carbon impact of installing those materials? This part is why durability is so mission critical. As mentioned earlier, if we have good natural insulation, for instance, that's torn off the building and then burned back into its basic components, then that carbon storage is no longer really that relevant. But if that happens, say 300 years later, and maybe it's composted instead, that could be a very different net result. This little phase here, the operational use of building in the red circles, this is when energy efficiency matters. And it matters. Energy efficiency is very important, but by looking so specifically and directly at energy efficiency above all else, we've missed looking at a lot of other important things. So material embodied carbon, or this stuff gets complicated because it's an area where there's still, I guess, some debate and way to go on as far as formalizing the language and vocabulary we use around these subjects. But in the terms of beam analysis and other things, we're mostly looking at these cradle to gate emissions, which is A1 through A3 of a life cycle assessment, which amazingly typically will represent 70 to 80% of the life cycle emissions. So if we want to get serious about carbon, we need to be serious about the materials that we use. Materials matter. I'm borrowing these slides from Chris Magwood, who you saw earlier. This is research that he did around the Toronto area in Canada. This is the same building, and we're looking at how different the upfront carbon is of this building, right? If you use high embodied carbon materials, you can end up with about 241 kilograms of CO2 equivalent per meter squared. That sounds kind of complicated, but just suffice to say that's a very high number per meter squared. If we pay a little bit of attention and try a little bit, we can get that building pretty darn easily down to about 90 kilograms of CO2 equivalent per meter squared up front. Still not so great. If we try really hard with our specifications, but really don't change our design that much, in other words, take more or less conventional code built building, but put good materials into it, or build a code building with good materials is probably a better way to put it, we can have a carbon storing building up front. And now the real kicker, the secret weapon here, if you will, that I think us as eco-builders should be very interested in, is by really maximizing both of our design, our long-term performance, but also most importantly, our upfront specifications, we can absolutely minimize and get to very, very significant levels of carbon storage upfront. So what does this mean over time? Over the next 20 years is what we're looking at here. This is again analysis from Chris Magwood's research. So we have this question mark there. That's our material carbon emissions. So how much carbon is going to happen up front? How much weight are we putting on up front before we start going on this efficiency diet, or this carbon diet, if you will? Well, if we're putting on almost 140 tons, that's about 315 years of operational carbon equivalent. At this point, it's pretty irrelevant what the performance levels of this building is, how energy efficient this building is. It doesn't really matter because there's no way we're paying back the upfront carbon in a meaningful timeline. The moderate case would be about 31 tons, and that's still 71 years of operational carbon equivalent. That's far, far, far too long to be meaningful. For the code built with good materials, low carbon materials or carbon storing materials, most importantly, we can have a building that's carbon storing for about 45 years. That's pretty game changing. Now, if we get all the way to the most aggressive type of design and material selection, we can be net carbon storing for almost 200 years. That is truly a game changer. And since not all buildings that we build, not everyone's going to hear this and learn this and care about this and change. So my argument is that if you can, we should always aim for this result. We might not get there, but we should always be aiming for as much carbon storage as possible. So summarizing this in one graph here, this is a high carbon materials, low efficiency building. The gray is the efficiency, the red is the material impact. In this case, we have a high carbon building that has high efficiency levels. High efficiency is great, but it doesn't do much for carbon in this case. Mid-carbon building, mid-carbon impact materials, at a low efficiency level. Noticing a trend here. The efficiency doesn't really make a difference as far within a meaningful timeline in most areas for carbon impact. It's the materials that make the difference. So here's our low carbon, low efficiency building. Still not necessarily so great if you think about that. So maybe we need to do a low carbon, high efficiency building, right? That's where we really get into some actual carbon storage potential. And then if we get really aggressive, again, maximizing our performance as well as our material selection, then we can get to a truly deeply carbon storing building. So recently I've been saying that material carbon emissions are greater than energy efficiency. In terms of carbon, that is across the board seeming to be true. Very rare to find that's not the case. Again, efficiency matters. We should do efficient buildings. But the thing we cannot sacrifice is using low carbon, good materials to build those buildings. That's the shift we need fundamentally. Because using that type of material puts us in the zone of actually saving our future. Or, as I like to say, the ingredients create the results. Havelock Wool, one of my buddies in the industry, they, I think, summarize this more efficiently and visually than most. If you think about the life cycle of where a material came from, you can trace it through well-treated sheep in New Zealand or beautiful forests being sustainably managed, or on the other side of things, say war for oil, big chemical factories dumping pollutants into rivers all over the world. Slightly different life cycles there. As mentioned in detail earlier, how do we find out what these ingredients actually are and what these components, these materials we're putting into buildings, what are they actually made out of? That's environmental product declarations, EPDs. There's definitely a way to go with precision in this kind of analysis, but the accuracy is within the degree that's necessary for creating meaningful results that are actionable, right? So yes, we have a lot of debate to go on precision and getting some of this stuff correct, but it's accurate enough to be very useful. So BEAM, what we all are here for. I've been beta testing this. It's a fantastic tool. EC3 I've used a lot as well. It's a really great tool. It's not I guess, simple enough necessarily to apply easily to residential scale construction, which is where I've spent most of my career, single family through small multifamily. So BEAM is particularly exciting to me. And in my beta testing has been absolutely game changing. So I'm going to walk you through the tool a little bit and then tell a story about using this. So the idea is, what's the carbon footprint of the materials for your next building project? Pretty basic concept. It's a relatively easy to use. If you like Excel, it's quite easy to use. It'll be in Google Sheets in the future. If you're not a big Excel analysis person, it might be a little more difficult to use, but yeah, that's to be expected for this kind of analysis. A good tool requires some good training and good skills. So it's a pretty simple process of inputting building dimensions, selecting from specific materials that you're using, and getting some nice automated results in the end. We'll go through this process and show you these steps. So some important notes. The results from this calculator are an estimate of the material carbon emissions of your finished construction project. Again, on accuracy versus precision, accurate enough to be very meaningful and useful. Is it as precise as can be? No, of course not. There's a long way to go on precision. This calculator is not intended to be used as a program or compliance tool. It's supposed to be an easy to use, simple calculator that can be targeted towards residential construction and making decisions in an efficient manner. And this calculator provides a range of possible material and construction technologies, but it certainly does not include every material available, far behind EC3 as far as the complete database and number of things in there. But you know, that's the story of this industry at the moment, is databases that need more inputs. So in the way that I've been using this tool, going through and comparing on a component by component basis has been really useful. Whole assembly analysis, like what is the carbon impact of this wall system versus Another wall system has been a very useful thing, but it's really been the whole building analysis that's so game changing in my experience so far using this tool. So just walking through it, step one, we enter some project info, pretty simple what it asks for. Step two is entering project dimensions. Again, pretty darn simple to find all this stuff. If there's a garage or other, units, we can add those into another form that's part of the first page, the first tab that you'll find in the tool. And for step three, I thought it'd be a lot more useful to show this through a case study I was working on with my buddy Jeremy Avellino out in Philadelphia. Runs a company called Brightcom, an absolutely fantastic group of people doing some very, very interesting projects. So it was an honor to look at this. This is a multi-unit, relatively small, less than 20 units, multifamily project. And through beta testing and this project in particular, I've come to believe that the BEAM tool is the missing ingredient our industry needs to move forward with verifiable low carbon construction, really at the asterisks at the residential scale. And that's really been a massively missing piece. So before we actually get into that part of the spreadsheet, it's also important to know the context of the building we're working on and look at our operational carbon, because I think the most useful analogy for people to grasp is how many years of operational carbon equivalent are built into the materials that we use in constructing the building. So this is a way to get a view of that. It can be fairly complex to figure out this information, but as long as you get within a reasonable degree of accuracy, again, that's usually good enough. So the first thing to ask is how many kilowatt hours per year is this building going to use? What's our predicted EUI? And then we can convert that to and I changed this to imperial units. BEAM is right now in metric, but it will have an option for imperial. I just found imperial's what most people work with around here. So the answer turns out to be about 250,000 kilowatt hours per year, but that doesn't necessarily have any, well, we need to figure out and look at how many pounds of CO2 equivalent exist per kilowatt hour, because that changes dramatically. In Tucson, it's very high. It's about 1.8 pounds. In Seattle, it's closer to what it is in Philadelphia, which turns out to be about 0.09 pounds, 0.1 pounds per kilowatt hour. And then we multiply these things together and we get an expected pounds of CO2 equivalent per year that's going to happen with this building. So in this case, about 24,000 pounds. And also we can look at that per square foot and have a carbon use intensity, and that's 1.7 in this case. Oh, and little pro tip, this is a photo from a project in Phoenix where we used Gutex wood fiber on the outside. And our carpenters got a little aggressive with the number of fasteners they used. And we found that that can actually have a significant challenge in terms of thermal bridging. So really be careful about how you place your fasteners and how many fasteners you use, especially when you've invested in really good insulation. So this is screenshots from the calculator I ran for this project. This is the Excel version. When it's publicly available soon, it'll be in Google Sheets for many reasons, making updates easy being the biggest. So I entered the project dimensions, and then we went through and defined assemblies and reviewed embodied carbon results. So I'll take you through that process quickly here. So in defining assemblies, one of the things that had been suggested by the energy modeling team is switching to XPS instead of EPS because it's R5 instead of R4. Well, it turns out that incremental increase in energy performance is certainly not worth the about 10x increase in carbon impact with XPS. This is again on average, but just looking at this generally for the sake of this presentation. And for the sake of not revealing all the details of this other project, I chose mostly the averages in this. Then we looked at flooring, for instance, right? Our flooring systems and our the inner floor cavities as well. And what was really interesting to find out is, given its FSC wood or really low carbon wood, 2x12s instead of TGIs for our floor systems could actually save a lot more carbon, create a lot more carbon storage up front. Very interesting thing to find out. Another thing, and part of why we didn't do Advantech in our own project, which you see on the right there, which is the Muse project in Phoenix that we're working on with those 4 units, is that Huber Advantech turns out to be kind of a hidden carbon bomb compared to good old plywood, right? It's about, again, wow, that time it's almost, it's like 8x. And if budget is forcing you to do laminate floors, which is often the case, it turns out cork laminate floors can be carbon storing, whereas typical vinyl flooring or other laminate flooring can be extremely high carbon impact. I didn't circle it, but you can see there that there's a type of laminate flooring that has almost 32,000 versus negative 3,564 for the cork flooring. So major difference there. Exterior insulation. This is a conversation I've had with a lot of people over time. Sometimes installing nothing is a lot better than installing high carbon impact insulation. Sometimes we can't afford good insulation. Sometimes the good insulation is definite, I apologize. Sometimes we're trying to go for a super high level of performance, and we're thinking that's going to be the right thing in terms of decreasing our carbon impact. But it turns out that if we use very high carbon impact insulation to deliver efficiency, it very likely is not going to have meaningful net carbon savings over the lifetime of that project. So mineral wool, relatively high carbon impact, but nothing compared to XPS. Again, this is a multifamily building, so these are some pretty big numbers. And then if fire code and building code and stuff made it easier to do good insulation in this type of building and, you know, multi-story, multifamily building, then these would be wonderful options to explore. Also worth pointing out that in this wood fiberboard category, there are quite a few products that are not even remotely carbon storing, and in fact have quite a high upfront embodied carbon. So all wood is not good if you want something that rhymes to remember it. Some key lessons we've learned for cladding. Well, I don't love thin brick. A lot of people don't love thin brick, but from a carbon standpoint, might be worth exploring. It really matters to specify low carbon fiber cement cladding. That's another very surprising thing that I learned. I didn't think they'd be that dramatically different in upfront carbon. And then taking a very careful look at what we're specifying for our interior cladding and thinking, can we move away from drywall and do something more natural potentially? Maybe not. We were looking at that. We are considering doing a bamboo plywood interior finish. If you see the number there, it's second from the bottom. Bamboo plywood turns out to be quite high carbon impact. So I'm glad we did not go down that pathway. And lastly in this, I just found this one kind of funny, but space age materials aren't worth using on Earth. Turns out, as you'd think, something that is going to provide R9.6 or R30 per inch, A, probably isn't that stable, but B, and expensive, right? So, but also the amount of energy that it takes to make something like that is just way more than we need for building products. It's pretty ridiculous proposition overall. So now let's look at the summary pages. If we used average building materials for this project, we would end up with about 152,000, this is in kilograms, so a little over 300,000 pounds of carbon up front. That ends up being about a 14-year equivalent of operational carbon, expected operational carbon, basically. If we use low carbon building materials, it ends up being a lot closer to 2.8 years built in. This is not that radical of a shift. And in fact, it has, in this assumption, removing exterior insulation entirely so that we can afford using carbon storing insulation inside and just making the walls a little thicker, ideally using T-stud or something to minimize thermal bridging. But it's amazing to see that with decisions that actually simplify this construction project and likely reduce upfront cost, we had an 80% reduction in our materials carbon emission through this analysis. Again, is it exactly 80%? No, but it's within reason close to 80% reduction, which is obviously quite significant. To summarize, I thought this was kind of fun because I've been trying to get people to care about this for about a decade now. And this has been my general experience. You get this look from architects, this look from engineers, this look from builders, and then your clients are just pissed off at you. That has been on repeat for me. I mean, not always, but a lot of the time, this is what happens, especially when you try to move this kind of conversation into more mainstream market. This is what I found the process to be with BEAM. People who normally didn't engage that much have been saying this is the most interesting information they've seen in years. I've been shocked to the degree to which people have been ready to digest this information and able to understand it well. So BEAM is coming soon. My question is, are you ready? There are going to be some new upcoming features added into there. I won't go through reading all of this right now, but there's a lot of work being done behind the scenes. Massive thank you to Eric and Chris and all the other members of the team pushing hard to make this happen. Coming soon, it's going to be free to download, free to use, and this will be available late March, early April this year. So getting very excited for this to be officially available. You can find this with Builders for Climate Action at their website, which is buildersforclimateaction.org. I'm going to stress again that BEAM is free to use. Please try to run it on every single project you do. I also want to acknowledge that in the current market, more than ever, capacity is a major issue, and a free tool isn't necessarily free to run. It costs paying employees or getting in an argument with your spouse or significant other because you're working on learning a new tool at night instead of helping put the kids to bed. That's not the situation I'm in right now at all. And long story short, there should be help available to run this tool, and more importantly, a lot of great training resources coming soon where we can learn online and through training courses how to run this tool appropriately. And that's the end of my time here. This stuff's often kind of stressful. I found this this pair of saguaros the other day on a walk, and it looked like one was comforting the other. So I put this little "don't worry" in there because I don't think we should worry. I think we should get excited. This is a time where we finally have the data and the tools to really make these changes. And I'll end with this. Who has been the hardest in the market to get to really care about carbon and building? Who have we been fighting against time after time? The finance people, right? It's the developers, it's the bankers, et cetera, et cetera. Well, the genius of this BEAM tool, in my experience, is it's done in an accounting language very specifically. And what I found is all of a sudden developers and financiers are jumping at these reports and saying, hey, this is stuff I understand. It's been very exciting to see. So I'll end it there and just say thank you so much for attending again. And please go to, again, buildersforclimateaction.org and sign up for when this tool is available. And then please do start using it. You will be blown away by the results.
Thank you so much, Lucas. That was fabulous. Thank you. And thank you for the time tonight. I know you are busy with your family as well, so we really appreciate the time. With that, we'll move right into questions. I am seeing one from George Ostro. This is a question for both speakers. Is there a help, and I was curious about this too, is there help or support groups or perhaps forums available for the EC3 and BEAM tool?
I can answer very quickly and say coming soon. Yes, that's the intent. In the meantime, if we're already in touch, feel free to contact me. I can point you towards the right resources. The team that's actually head down developing the tool is quite busy for the time being, getting ready for the launch at the end of March.
Yeah,
Yeah.
I can just add that we're going to be getting some live video tutorials, probably somewhere around 3, and that will help develop a training course and documentation and such that you can help you, you can learn with.
And for EC3, we do have some video tutorials on our website, so just drop the link in the comments. It's buildingtransparency.org/resources/videos, so it's fairly straightforward. We don't have a dedicated forum, but we do use the Carbon Leadership Forum. So if you have any questions, I also dropped the link for that one in the comments. There are some questions that people have already asked about EC3 as well as Tally, and there's also the general embodied carbon questions in there. And I think the last way that you can also get in touch with us is either email me directly. I'll also share my email here. But on the EC3 website in the bottom right corner, there's report bugs and feedback button. You can also use that button to either ask questions or let us know that something is confusing, or if you find any issues with even the data in there, so you can use that button.
Thank you so much. And during these questions, real quick, I'll add, please feel free to turn on your cameras, turn on your mics. These end of question and answer sessions are meant to be collaborative and very, very just discussion based, as well as as if we were live. So please, take advantage of the speakers being here tonight to get those questions in. I have another question for you. For the EC3 tool, please explain conservative and achievable again.
Yeah, so for let's say when we have a collection of EPDs, let's say I have 10 different EPDs, right? We look at the statistics of the carbon values across those 10 EPDs. And the achievable and conservative values are pretty much the 20th and 80th percentile in that sample set of 10 EPDs. The conservative is the higher value, so that's the 80th percentile of that data set, and the achievable is the lower end, the 20th percentile. Obviously, if you have just 10 data points, that's not a fully representative sample set, right? If you are into statistics, but we also do consider industry-wide EPDs in some of these comparisons, and we actually weigh those a little bit heavier. So for industry-wide EPDs, that sort of sets up that potential range within the entire industry. And then we also add the product-specific data points to show you where they are in that industry-wide range. So I hope that makes it a little bit clearer.
Thank you. Yeah, and George, if you have anything to add, please feel free to do so. And a third question, what if a user does not know what value to input or what unit of measure to use? Are there hover options or hover tips when you select those categories?
Yeah, so the way that I was defining in my building project is that I enter the quantities and the unit first, right? It's probably better to click the search button first, look for your type of material that you want to input into the building. And then once you select it, it actually fills out the unit itself. So it tells you automatically which unit it's looking for.
That's a great function. Thank you. Looks like we've got one more question from George. Where does BEAM get its data and EPDs?
Our original database came out of Chris Magwood's master's thesis work. So he spent a long time really just going into each EPD and pulling out the information and throwing it into a spreadsheet. So that's sort of the foundation of it. It's a little unwieldy to look at that spreadsheet, but it's home to me now. Yeah, when I came on, I was verifying some of them. I was adding more, and we try to keep an eye on what's going to be relevant for the home builder sector. And we're a little bit different from most other LCA tools in regards to our inclusion of some products. I know this is a bit more than what your question was asking, but I feel like it's good to mention. We included some materials that where their source is actually from LCA studies that were peer reviewed through academia. So they don't all come from EPDs, but when they don't, we make it really transparent and clear where it came from and that it's not from an EPD, and use at your own discretion. But it does allow us to use some of the materials like cob and straw bale and some of those some more carbon storing materials that maybe aren't far enough along in development or are more broad than, or not product based. They're more of a material than a product at this point. So we wanted to be able to include those to show some other opportunities. That's for myself and for Chris, like that's our background has been really focused on natural building materials. So we've built with these materials we're including, yeah, we're happy to include them, promote them.
Thank you, Eric. And I apologize, I didn't get a chance to introduce you. Eric, do you mind also putting your contact information and just giving a quick intro of you and your position with the Builders for Climate Action?
Sure. I'm the lead embodied carbon analyst, and I've pretty much been the developer of BEAM since I came on December 2020. And yeah, so I've been involved in various research projects where we've used BEAM internally to run studies for cities and do policy advising and looking at specific buildings, etc. But yeah, so myself and a few others are hustling right now to get this out to you as soon as possible. I know there have been a lot of people who, kind of knock on our door every week or so, just hey, is it out yet? But yeah, it's coming soon. We're trying to get it out there. Yeah.
Awesome. Thanks so much, Eric. And yeah, if you don't mind putting your contact info in the chat so folks can get a hold of you with questions, that'd be great. And then I have a question that just came in from John. Could you talk a little bit about efforts to include incentives and code changes to encourage the reduction of embodied energy in buildings? And John, I will say, apologies for the rowdy dog that I've got here. I will say I do know Kirkland, City of Kirkland is looking into this as a code amendment. And I can send you the lead person on that project. His name is David Barnes, and I can get you in contact with them. But between BEAM and EC3, are there any incentive or code change or any sort of local jurisdictional work you all are doing?
I can go ahead. On the EC3 side, we have worked with the Buy Clean California initiative in terms of actually requiring disclosure or sharing EPDs for any of the state projects in the state of California. There have been a couple additional efforts, I think in the state of Washington. I think King County was working on something along the same lines for any of their municipal projects where they were going to ask manufacturers for EPDs and really use it to start benchmarking some of this work and potentially start setting thresholds in the future for what type of materials can be produced in projects. We also encourage, obviously just asking for EPDs in the first place right now. Not everyone has them, so there's a lot of product categories where we don't have a lot of understanding of the ranges across different manufacturers. but we also encourage, putting, let's say, monetary, rewards into the bidding process for commercial projects, or incentives, where if you are the lower carbon manufacturer of a particular type of product, maybe that's somehow accounted for in the bidding process. There's also a different approach by putting carbon price on materials, and also putting that into sort of the cost structure of especially commercial buildings. It's slightly different for residential projects.
Thank you. Yes, and thank you so much, Kinley, who's on the line today with King County Green Tools and King County Solid Waste Department, that they are also working toward requiring EPDs for all King County owned projects as well.
Can I also add a little bit, Nina?
course, John.
Washington State, I was just on a seminar on this last week. Washington State has a bill in the House and the Senate on reduction of embodied energy in buildings in the built environment. Neither bill got out of committee this session, but they're going to be resubmitted next session. And I think it's very worthy for us to look into supporting that and helping them modify it into something that's highly workable. They also mentioned that Oregon and California also have state bills under consideration as well for major embodied, and as well as the city of Vancouver, BC has done quite a bit. That they have a strong target of reducing embodied energy in their buildings by 40% by, I think, 2030, something to that effect. It appears that they have the most developed system for incentives, which hopefully all of us across the country and the world will be working on soon.
Thank you so much, John. That's great information. Thank you. Looks like we have a great question from George, which I often think about too, for both speakers tonight. Is sequestered carbon a joke, like carbon offsets? What would you kind of, what are your reactions to sequestered carbon?
I think that's a great question. And I'd love to give the first answer. So yeah, it's really good to be skeptical. I think good for you for asking. The difference with embodied carbon having what's considered carbon storage is that it has it's kind of where the word embodied makes more sense. Like the carbon molecules have been absorbed from the atmosphere and turned into biomass. Usually it's biomass. And then it actually forms usually around 50% of the material by mass with carbon. So it's literally forming its body out of the carbon from the atmosphere and storing it in the physical body of the material. And as long as you don't let it rot, be eaten, burned, decomposed and released back in the atmosphere, it's able to hold that carbon. And storing it in a building is, one of the best places that we could put that. So, as long as it's within that building, it's holding it. And yeah, I'm familiar with the criticisms around carbon offsets. That's a really complex system, but this actually is pretty simple when it comes down to it. Photosynthesis is the main way that this happens. Like the leaves turn sunlight and carbon dioxide into their physical bodies, and then it's stored. So, what happens after that material is used at the end of life? For a lot of natural materials, they can be they have different paths, but some of them could be even creating soil, going directly back into the earth because they haven't been given treatments that would make them harmful for the environment. So there's that to consider, but for the duration of the building that it's holding on to, it's making a significant difference. I'd love to talk more, but I'm going to stop there.
Yeah, I'll just add that definitely it's not a joke. It's real. right? But there are some nuances to it. So as Eric mentioned, I mean, when trees grow, for example, so mostly sequestered carbon is related to bio-based materials such as wood products. So when the tree grows, it sequesters carbon. That's all true. What you need to think about as a user of that product is that wood actually sourced sustainably? Is it being replaced by another seedling and another tree that will be allowed to grow for the next 40 years or so to its full size, right? So that's one of the aspects you need to consider in this on this topic. The second aspect, as Eric mentioned, is what happens to that wood at the end of life. This is why we're calling these carbon storing materials. The carbon is stored in that wood product until whatever you do with it, after the end use of that product. If you incinerate it, all of that stored carbon is fully released back into the atmosphere. There is still a benefit of using wood products over some of the fossil-based products because that carbon that is stored in the wood is still part of the natural carbon cycle that's relatively short time scale. Within relatively, I mean, let's say, those 40, 50, 60 years that a tree grows and sequesters carbon from the atmosphere. When we use fossil resources, we actually dig up materials with carbon that has been in the ground for thousands of years. And if we release that carbon into the atmosphere, that's what more concerning than some of these biogenic carbon emissions as we talk about them. So those are just some of the nuances to think about when talking about sequestered carbon.
Yeah, I would like to add one more thing if possible, just because one of the things that we have really looked at and kind of gone taken quite seriously is sourcing of wood. And for the moment, for the moment, we've decided not to credit wood, like virgin log wood, with carbon storage, because there's, the debate is still ongoing. The methodology around accounting for that is still uncertain. People are working on it. I've spoken to a lot of them, and it's quite a complex, because you're working with living systems and determining the scope of the boundaries of what time frame you're looking at and how broad you're looking can change everything. So anyway, it gets complex quick. So we've decided, until there's sort of more consensus and standard methodology, we're not crediting wood, raw log wood, but we do still include annual crops, straw and or short grown crops, and agricultural byproducts, other sort of secondary use materials. Just wanted to throw that in there. That's a good point.
Thank you both. We've got a couple more questions here. So this is a question for EC3 tool. Sounds like folks are interested in knowing kind of when to use EC3 tool. Is this folks have tried using it for residential buildings, and it was hard to find some materials. Would you recommend using it only towards commercial or some multifamily buildings? What would you recommend?
Yeah, that's a great question. It was definitely geared towards commercial construction first. It's also, as mentioned, it's purely built on environmental product declaration data. And for some of the materials that are used in residential buildings, there just aren't enough EPDs in some of these categories, which is also why the BEAM tool is really helpful from that perspective. It doesn't just rely on environmental product declarations. As Eric mentioned, it does include some generic LCA data that's based on academic studies and other things. We are planning to include some of the generic data in EC3 as well, but as of right now, it only uses EPDs, and most of the focus is on commercial constructions. There are also some material categories, as I showed early on in the demo, that are currently pilot categories, and so we're still developing some of those categories I think, as soon as we release them publicly, you will be able to account for some additional materials, even for residential projects. But overall, yeah, we still have some improvements to do in terms of providing more generic data to users, especially for residential.
Thank you. That's super helpful. Another question from George regarding EC3. Does it help pick the lowest CO2e concrete, but does it also decide to use steel instead of concrete?
It doesn't do that automatically, but it can help you arrive at that conclusion, right? So we don't have sort of basic quantity estimates for different types of construction. We completely rely on the users to input their material quantities for particular projects. So if you did have, let's say, two structural systems, one using concrete structure and another using steel structure, you could input those quantities and then compare those two projects in EC3. And it would tell you, right, which one is most likely lower impact than the other. But you can't really just compare 1 cubic meter of concrete to 1 ton of steel, because those are different types of units, and you need different amount of quantities of those materials in your project. So we don't really help you with that off the bat. You need to do some more work.
Thank you. We have a question from Jake with TC Legend Homes. Welcome, Jake. Question for Lucas, actually, if you're still on and available. Do you publish lists of top-level generic MCE values for different assemblies so a designer can make assembly choices based on carbon in addition to cost? Example, concrete parking deck versus lumber parking deck, or SIPS wall versus a stick frame and wood fiber insulation wall?
Totally. And sorry, I disappeared for a second. We're dodging children and stuff in the background now.
No worries.
So long story short is no, not yet. That's a great idea. It's something we've thought about, but it's a bit early in our personal data analysis process. We like to have hundreds, if not thousands, of data points for things before we put stuff out there. And it's also just been kind of hard. We tried to do a similar exercise running BEAM to create some generic kind of don't do this, do this type things. But so often the answer is really whole building dependent. Like, what are we doing for the floor system if we're looking at the wall system, and how do those things relate? Maybe if we're doing a elevated concrete free carbon storing floor system, which would be an amazing thing to see. Hopefully our next big thing at Valley that we do down here in the desert. But that means we could be a lot less aggressive with our carbon storage and walls potentially, right? So without the context of the whole building, I get nervous about putting that information out there and people looking at something incomplete and making decisions from that. And making decisions from an incomplete data set is almost more risky than making decisions from no data in some ways, because now you're very confidently steered the wrong direction. So that's a longer answer than I intended. But in other words, I would love to see something like that out there, but I'm not really sure how to make it useful without.
Can I comment?
Sure.
Can I just throw something? So here it is. We design like 5 or 6 residential houses a year, and we're an eco builder. We build net zero houses, and we got to make decisions. We build SIPS houses, and they're just it's something. This is a new carbon it's a new thing, embedded carbon, and so there almost isn't an entry point. That there are these wonderful tools, and I get that the EC3 tool is insanely granular and amazing if you're going to build a multi-story building, and your tool is fantastic if you're going to build a residential building. But what about the generic person who's just entering the industry? I just need to know if I didn't know how much worse XPS foam was than EPS. So it's 10 times worse by the looks of things at a generic level. So it's just about making generic decisions at the beginning of an industry, and it's just a basic list. And my point is that to inform the novice is that it would be great if you could own that space and say, hey, novice, these are some rough, you could call them rules of thumb, and that would be really helpful for us as a business.
That's a great point. Now I have more clarity on what you're asking. I would say the best tool I'm aware of for that need would be the Carbon Smart Materials palette that was put together that we briefly mentioned earlier. That's definitely the best out there I've seen as far as just, you can go find insulation, for instance, click on different insulations, read a bit about them. Not too deep of a dive, but good summary level stuff. And I've even sent lots of clients to the Carbon Smart Materials palette because it's a really good like client level or intro level.
Well, and also an everybody level. If the math says this is as important as we think it is, it's way more important having a net zero building as having a low embedded carbon building. It's actually really grossly important, almost to the press as well. So anyway, that's a great resource. Now I'll go and take a look. Thank you for your answer, and thanks for the good tools.
And just to clarify one thing on that too, I mean, net zero is where I started. I love net zero building. It should just be both, right? This is one of those everything bagel movements. Like we got to use everything we have to minimize our carbon impact. And beyond carbon, even if we succeed in minimizing carbon impact, we still need buildings to be durable and healthy and power themselves. So net zero is still mission critical part of the future. It's not saying that's bad. It's just saying, let's do net zero, but with good ingredients, right?
No, it's okay. I get what you're doing. It's all good.
Yeah, absolutely.
Thank you.
I need to clarify that every time, because usually when I do these presentations, people will follow up and like, you were hating on efficiency. And I'm like, no. Efficiency.
No, I get you.
All right. Thank you so much.
Thank you.
Thank you, Lucas, and thank you, Jake. And we have one last question from George, and I think he has just a follow-up question. And George, please feel free to elaborate if you'd like, but is counting sequestering fair if it was going to happen anyway, such as a tree growing? Does any of you two want to take on that question? George, feel free to follow up if you have anything to add.
I think we would need a couple of hours to talk about that, to be honest. It's a very, there are so many different ways I could branch out and start talking about that. And feel free to get in touch with me if you want. We can chat. There are a lot of different factors. Even just defining the word fair in this is just one thing that we could talk about for a while. Yeah,
I agree, and I guess it goes to let's say how the forestry companies or whoever is managing a particular forest, how they're actually managing it. If they're afforesting something, if they're reforesting a part of a land, they should be able to take some credit for some of those activities as well. And I think this is where this discussion started from. Is basically they can potentially help us in sequestering carbon and storing it in materials if they do it right on the forestry side, right? Now, again, we have all discussed some of the nuances here, and I think that's the reason why a lot of these LCA tools actually don't like to account for the sequestered carbon, or they put it sort of in a separate category. They just tell you this is the potential sequestration. You can account for it or not. You will hear a lot of architects talk about sequestering, carbon, but I think it's always better to account for the embodied carbon and the sequestered carbon separately, because it's such a nuanced topic. And so, for example, in EC3, we don't show you the sequestered carbon in the GWP values, in those carbon values. We provide it as a separate informative value. And I think Beam does something similar for some of the products.
Yeah, we show both. We show
Yeah.
emissions separate, and then we show the net. Yeah. And wood tends to perform really well whether you count storage or not. Like it's lower process, like compared to its alternatives of concrete and steel. So regardless of whether you're counting those credits, it tends to be a really good solution. It's especially applicable in the residential and low-rise building sector. So it's kind of an easy win. Because a lot of buildings are already using it too. So
There's also a industry jargon versus technical meaning situation to some degree here. In my grad program, sequestration meant a phase change of carbon that's permanent into a material, right? Versus carbon storage, which would be short term and in like wood growing or sheep wool or something like that, because that's a relatively short term thing versus the, sequestration happens over eons versus hundreds of years, right? So it gets a little confusing, and I'm not sure which one we necessarily mean, but generally sequestration and storing within our industry are kind of said as the same thing, even though they're significantly different technically. So further confusing the point. You're welcome.
Yeah, I mean, just a comment that, the problem of climate change is caused by burning fossil fuels from, millions of years ago. And so to take credit for stuff that, grew in the most recent century and then apply it to a million-year-old problem seems like you're sort of double dipping, it's just like, it just doesn't seem like it's really part of the solution. And I don't know as you need it. In other words, wood is still a low carbon, if you ignore the sequestration, it's still better than steel, right? It just seems, it seems like it's gaming these calculators in an inappropriate way by sort of, it's not keeping everything in the same sphere or same bucket. But yeah, I agree. It's not straightforward and simple. It's a day-long discussion with no clear conclusion.
but yeah, it's that kind of caution that we're also using, and why we haven't decided yet to give raw log wood credit yet in our tool. And yeah, you really do need to consider, even beyond carbon, like what this is doing to ecosystems and social justice and other factors too. Not that our tool deals with that, but it's something that I think more and more we need to include in the conversation.
Because you think about it, if you sort of follow the direction that the tool is giving you, you leave all the iron ore in the ground and you go cut down all the forests, and you're like, we're good, right? And it's like, well, we kind of need those forests, and they were kind of there all along, and it's just, right? Yeah,
there's some interesting impacts of forestry that really surprised me. And this isn't a conclusion, this is just some really interesting information that made me think a little differently about the sectors. In the last, I think, 20 or 30 years, we've gotten certain forestry practices have gotten so good that where their forests are managed, they're able to sequester a lot more carbon than nature would on its own, just through better management practices, which was really interesting. Like, how are we doing it better than nature would just do on its own? So there's when you're valuing wood, you're also encouraging people to take care of their forests better. So there's some impact of valuing the forest, and that we don't want overforestry, like overforesting. But what we have, what there, records going back, I think 100 years were showing us that when the value of wood went up, forest carbon went up. And that sounds really counterintuitive, but it's because people invested in their forests. They managed them better. They became more valuable to people. Just like I'm broad strokes here, like, and it's not my field of expertise. It just, yeah, just, and those aren't that's not my whole perspective. It's just sort of, it's not always as straightforward as you think. And when you cut down trees, more saplings and other life grows in its place. And then there's also the difference. I will stop after this next sentence, I promise. But there's a difference between in storage rate, depending on the age of the tree. So I believe it stores a lot more as it's younger, and as it gets older, that kind of tapers down. So there, you know, it needs a lot more analysis. You're also kind of looking at, like, are you looking in the past at what happened before you cut the tree down, and land use change, the effect on climate in that way. And anyway, I broke my promise. I said I'd stop. I'll leave it there.
I mean, the summary I have is use good wood, right? And all wood is not good. So be very careful about which wood you're using, but good wood is our magic ingredient. But we do have a ways to go. If Kinley had mentioned in the comments, if you know, we can build with reclaimed wood, of course, amazing, right? That's clearly a wonderful thing. It's hard to find studs that are even remotely as good as the ones that were used in the 1950s, right? But that's hard to do at scale. And luckily, especially in the Northwest, there has been, as Eric is saying, tremendous leaps and bounds in forestry management that has led to, again, yeah, as you were saying, more carbon storage per square foot of forest than in virgin forest. And especially with cyclical forestry, where you're allowing the growth cycle for the first 20, 30, 40 years before you're cutting the tree down. That is when the maximum carbon storage per time happens. So that stuff starts making sense. But yeah, below all of this is a bunch of academics hotly debating all of this stuff, being married to one. I see the behind the scenes of that all the time. So in conclusion, I think it comes down to that accuracy versus precision thing. Is there a long way to go on precision? Yes. Are we at the point where it's accurate enough to be meaningful? Again, yes. So you kind of have to hold both things at once. It's here-ish, we could get it to there-ish as far as precision, but we know what we're aiming for is over here, not over there. How precise do we have to be on that target? I don't know. But what we know is we don't want to use a bunch of fossil fuel-based stuff. We want to use natural stuff. Probably put through the same high-tech manufacturing process. We've done a lot of great stuff in terms of manufacturing, but we just need to put good inputs into our high-tech systems, and we have a much better chance of having a better built environment.
Isn't the guts of it about replacing, to Vaclav's point, isn't the actual guts about this discussion about replacing the earth materials, which are net importers of carbon dioxide into the earth system, which were totally locked up, replacing the earth materials, their carbon emissions, with forest materials, which are basically a sort of a zero-sum game. The tree grows, it lives its life in a building, it rots out, goes back to carbon dioxide, but that's, it's a very rough analysis. Isn't that where we're at as choice makers, is not using earth materials and using lumber? Could that be a generic learning? There are obviously loads of others as well, but
yeah, it's basically using materials that are occurring within our geological cycle. If we're using materials derived from eons ago of stuff that's happened on our planet, that's probably not within a relevant timeline as far as our this carbon cycle, if you will. So it's not just forestry, it could be, sheep wool or something too, right? But it's using products that occur naturally, that the finding and harvesting process is, oh, there's a sheep, there's a tree, instead of like, oh, there's fossil fuels somewhere way down there. we got to dig it out, fight a couple wars for it, and right, that whole process has just not worked out for us. And to be a little radical about it, I mean, efficiency has been a really, really easy thing for America to get behind, because it's been buy a bunch more of the bad stuff we were already producing. Whereas embodied carbon is a pretty radical shift in thinking of no more bad materials. Like, we can't design out the embodied injustice, the embodied carbon. Those things can't be designed out of those materials. They're built into the materials, and we need to use good materials. My wife turned off the light. Now I feel like I look way more epic than I mean to at the moment. I hate seeing myself on camera so much. I'm gonna just stop now.
I will just add to that that it's generally true that some of these bio-based materials are better, but it's not really the raw materials or a lot of the times that are actually taken out of the ground, like let's say iron ore, that releases carbon into the atmosphere. It's the process to make steel that releases most of that carbon. And so we can actually, there are technologies on the way where we could theoretically manufacture zero carbon steel. It's just not how the market, how the majority of the steel in the market today is manufactured. And it's probably unlikely that we should really make everything out of wood, right? As George mentioned, we can't just mow down all the trees on Earth and build everything out of wood. So we're going to need all these materials. It's a matter of pushing on our manufacturing supply chains and manufacturers, and giving them this incentive that they should be actually investing into these innovative technologies and making it competitive to be a low carbon material manufacturer. And that starts with us builders and architects and everyone around asking for information about these products.
I think one thing that we're seeing and a lot is talking about mass timber, and that when people talk about carbon storage, it's almost always about wood and trees. I think that part of that is just because those are that's sort of the main material that's available for larger buildings. But residential, smaller buildings have been the sandbox for the last 40 or 50 years of building with straw and hemp and cob and cordwood and all these different sort of materials that are really low process. So using very close to what's coming out of the ground without much processing, and sort of fast or short cycle crops. Like in Canada, there's something like 20 million tons of straw that is a byproduct of the agricultural industry, and most of it gets burned. Some of it gets tilled back in, but really that's such a lost opportunity. If we stored that in buildings, it would be quite enormous, the amount of carbon storage we could get. But it's those types of materials have mostly been incorporated into more residential buildings and small buildings. So we have more options. I find that exciting for the home building industry. And there are quite a few products coming online that use those. And some of them have been around for a while. I mean, cellulose itself can be considered carbon storing. And that's become quite readily available. So
cellulose is definitely the gateway drug I've found to low carbon materials, because a lot of people are using it anyway. It's pretty easy. I get a little nervous about moisture and toxicity in some cellulose and whatever, but design your enclosures well. Generally good piece of advice. And on the note of low carbon steel, yes, please. If we can have carbon neutral steel, oh my God. Like, there are some details that would be a lot easier in our buildings if we could do like the spans we want to do, for instance, that would be lovely. And we have actually some steel in our current building. And we would have loved for that to be zero carbon steel. Turns out fighting structural engineers is very challenging. So we got stuck with steel, even though we asked to have none. Yeah, it's wonderful to see the market continue to be pulled towards verifiable low carbon construction, right? I think that's the whole point of this. So create the demand. If you're attending tonight, we got to wrap up now, so I'm going to end this. If you are out there in your conversations, I beg you, just bring this up. Start talking about embodied carbon. Start trying to run these tools. Start asking if people have LCAs, the manufacturers and suppliers that are going to come to your office and do lunch and learns. I was that guy once. People appreciate those questions, and the market changes and adapts to respond to those questions. But we have to ask, we have to create the demand as professionals. So let's do it. And with that, I think that's done. Nina, do you have any closing words?
No, just that. Thank you all again so much. Thank you to our sponsors. Thank you to our speakers. A lot of this information and links, as well as contact info, will be shared in a follow-up email if you registered online or if you are affiliated with the Guild. We will be sending that information. Thanks so much for the questions, George, Jake, John, also Nicole. Thanks for your questions that you posted in the chat. We really appreciate your involvement and just very great discussion going tonight. I appreciate it. Having said that, please check out our upcoming events. We have some discussion already going, and you can check out those links, and I'll send those via email as well. I just want to wish you all a very happy Wednesday night and enjoy the rest of your week. Thank you again so much for everyone's involvement. You too as well, Eric. Thank you for joining in on our discussion this evening.
Thank you for having us and for organizing everything.
Thank you.
Thanks, everyone.
Have a great evening.
Thanks.
Bye all. Thank you so much. And I'll see you tomorrow, Kinley. Yeah. Thanks so much.